All right, going to do a deep dive into coding the simple moving average, the exponential moving average, the weighted moving average inside of ThinkOrSwim using ThinkScript. ThinkScript is a language, coding language inside of ThinkOrSwim. ThinkOrSwim is a brokerage software that is run by TD Ameritrade previously and is currently being transferred to Charles Schwab. So we're going to talk about, they have built-in functions in the software for these. We're going to talk about those first. And then we're going to look at how these are actually calculated and how we can do them long form so that we can adjust them around a little bit more if we want. A lot of stuff to talk about here, so I'm going to go a little fast to try to keep this short. So we're going to be on the charts here. You can, any chart you want, but I'm under charts. Come over here to studies, edit studies. And what we'll do is we'll start out by creating a new study here. And we can type this out by doing simple moving average is under simple moving average. Let's see, what is this? Whatever this one is, simple moving AVG. And then you would put, so if we're trying to do the 9 simple moving average, it's going to be the current closing price, which is what? If we haven't reached the close, it's the current price for the current day, and then the closing price of the 8 previous days. Closing price being the price at 4 p.m. on that given trading day. We're going to say 9 there. What the simple moving average is it's just taking that current day price and those prior 8 days, and it's adding them all up, and then it's dividing by 9. So it's the simple formula, and that's where it gets its name from. The exponential is going to be under a different syntax. It's MOVAVG, then exponential. Same thing here, close 9. And then the weighted is under the same syntax, MOVAVG weighted. Close 9. So I'll go ahead and apply that, and we can see that those are charted on there. The blue is the simple, the red is the exponential, and the gray is the weighted. Now these are codes that have been written by ThinkOrSwim, and they have parameters. They got 4 parameters to them. We come over here, we can see, we'll click on the little gray name, we can see the parameters over here, also called inputs. Price, this is going to be what price we're using in the calculation. So we're using the 9 prior closing prices, but we can do a litany of different things, high, low, open, different stuff there. Length, this is the number of days. And then we've got 2 down here, displace. And so when we're calculating the current day and the prior 8 days, what's going to happen is that level is going to change all throughout the day because we're using the current price as one of the parameters in the calculation, and because that's constantly changing, it's going to constantly change the moving average. So if we wanted to have, instead of doing the current day and the 8 prior days, we wanted to just do 9 prior days and have it not move at all, we can displace this 1, and that's what that would do. It would change the formula. And that's really the only useful thing displace would be for. But if you wanted to do it even further, if you wanted to exclude the prior day and do like day 2 through day 10 or something, you could increase that more. So those are those. And then show breakout signals. And this is where this one doesn't work in here. I'll show you how to get it to work, but it can lead to some confusion because people come up here and say, okay, well, let me do this breakout signal, and then you apply it, and it's nowhere on the chart, and that can be confusing. So the issue here is that these are codes written out by ThinkOrSwim, and when we call these inside of our custom function, the show breakout signals doesn't work. We have to directly call these functions through typing them in here in the studies. So if we wanted to do simple moving average, we would do simple move AVG, and then we could, what you'll notice is this is locked, okay? It's because ThinkOrSwim wrote this, they lock their things, but they allow us to copy these and edit them around if we want, but we just need to do it inside of a new study. So I'll do that, and then we can come over here and change this to yes. And then when we apply this, what you'll see is those arrows are now there. It's indicating, see the up arrows are green, the red arrows are down. You can change these colors in here by coming into the study now and editing the colors down here to whatever you want. Up tick is the green up arrow and down tick is the red arrow. So that's how that works. The last thing I want to point out is that we're currently on the daily chart, and so it's doing the 9-day moving average. But if we come over here to an intraday chart, and let's choose 5 days and 1 minute, that's fine. You'll notice that these are very close to the price action, and so this is now the 9-minute moving average. It's going to use the candles on whatever chart you're looking at, and so because we're looking at minutes now, it's doing that. So if we wanted to see continue to see the 9-day moving average for these moving averages, we'd have to specify that. Do it by coming up here, typing input, and we would say do AGG equals, it's probably not the best one to use, but AGG equals aggregation period dot day. We'll end it with a semicolon, and that tells it that we want to use the days. And then down here on the close, we'll add parentheses and say period equals ag. We'll do that for all 3 of them. Okay, hit apply. We'll come back over here and we can see that now we have straight lines across every single day, and that's because we're using the daily calculations, the daily data on these now. So every single day has the same line regardless of the candle for that given day. So you're going to have straight lines all the way across for the entire day. So now let's look at how these are calculated. Like I mentioned, the simple is just simply calculate all 9 prior, or the current, and then the 8 prior numbers, and then divide it by whatever number it is. Exponential is calculated as a bit of the exponential and the weighted are a little more difficult. And so this right here is the formula for the exponential. You're going to have smoothing constant, and we'll talk about that formula there, times the difference between the current price and the prior period exponential moving average number. And then we add the prior period exponential moving average number. The smoothing constant is 2 over n plus 1, n being whatever period you want to look at. So in this situation here, we're looking at 3 SMA. So the smoothing constant would be 3 plus 1 equals 4 on the denominator, and then 2 on the numerator. That would give us 50%. So we can see the formula here, 50% times the difference between 463.06 and 454.98, and then we're adding 454.98, and that gives us the 3-day EMA for that given day. And then the weighted, come over here, you can see this picture here. P1 here is the most recent stock price, and then P2 is the day before. So if we look here at this 464.03, we're timesing the 467.69, which is the price for this given day, by 3. the prior day, 463.06, we're timesing that by 2. 454.98, the one from the day before yesterday, timesing by 1. And then we're dividing that by adding up. We start with the number that we're using, so 3, and then we add up every single number that's smaller than it. So 3 plus 2 plus 1. If we were doing the 9 weighted moving average, it would be 9 plus 8 plus 7 plus 6, etc. And the number would be 45 there. All right, so I've got these set up, simple, exponential, and weighted. Let's talk about another way that we can write these outside of the functions. So for the simple moving average, we could say average close 9. And remember, if we want to always be daily, even on the intraday charts, we would do period equals AGG on the close, and that with a semicolon. So go ahead and apply that. We'll look and see what that looks like. And just for the sake of ease, I'm going to come over here to the daily. All right, and you can see we've got 2 lines plotting here, and they're both the same number right up here. Where my cursor is, you can see those 2 numbers. The first line is always going to be blue, and that second line is always going to be red. So the one that we just typed out would be in red, but it's behind the blue line, so we can't see it. But we can see from those numbers up there that it's plotting directly the same thing. All right, so let's talk about the more difficult ones here. First, we'll start with the exponential. So if we wanted to write this out long form, what we would say is we need 2 different things. We need the smoothing constant and we need the formula. So the smoothing constant, we could say DEF smoothing constant equals 2 divided by whatever the length is. So we'll say EMA length plus 1. Now we need to define the EMA length. So we'll define that with an input. That's going to be 9, and that represents what this is right here in this formula. So we're just saying we want the 9-day EMA. Okay, and then with that in, we'll do DEF EMA manual, just giving it a name. It's going to be our smoothing constant. Times the close. And we're going to put period equals AGG. Then we want the prior EMA. So how we're going to do that is EMA length, EMA manual and then we add the prior one, so EMA manual 1. So what this 1 in brackets means is it goes back 1 value. So it's going to say whatever the prior day EMA was, we're going to use that number. And then once it runs this formula, it's going to get a number, and then it'll overwrite EMA manual with that new number. And we'll come down here and we'll plot this, plot E. You can see this thing keeps autofilling. What you can do is you can come up here to options and turn off autocomplete. And we're going to plot E equals EMA manual. All right, we'll go ahead and look at that. All right, and you can see there's only one line visible, but again, if we look up here, we can see that there's two lines plotting and they're both the same line. So what this does is it allows us to change around the every single possible variable that we could possibly change in the EMA. So if you wanted to change the smoothing constant around, maybe you wanted to experiment with using 5 here instead of 2. If you wanted to add, 10 here instead of 1, whatever it is that you wanted to experiment with, if you wanted to adjust the formula that they use, do your own hybrid exponential moving average, you can do that with this long form code here that plots the EMA. You can't do that up here because this is something that's built in to the software. So here's what weighted moving average is going to look like. We're going to start out with an input, WMA input equals 3. And then we're going to break this down by numerator and denominator. Start with the denominator because that's the easiest. So remember, we were adding up, starting at whatever that input number was and adding up every number that was smaller than it. So in this case, it would be 3 plus 2 plus 1, which would equal 6. Here's another way that you can write that so that it'll automatically calculate that number every single time. Say WMA input times WMA input plus 1 divided by 2. So what's that going to be? 3 plus 1 equals 4, divided by 2 is 2, and then we're timesing 3 by 2, and it's going to give us 6. Numerator is going to be a little tougher. This uses a fold function. Fold is a loop. So if you're familiar with like Python, whenever you're doing a for loop, that's sort of what fold is like. It's we're going to say fold I equals 0 to WMA input. And so what this is going to do is it's going to cycle through 3 times. The first cycle I is going to be 0, and it's going to go 0, 1, 2, and it'll stop at 3. We're going to say with S, do S. So what this is doing here is, remember that for every single number, we wanted to times it by a certain, we're taking that closing value and timesing it by a certain number. So the very first, the closest close that we were looking at, we were timesing that by this WMA input, and then the one before that, we were timesing by this number minus 1. The one before that one, so the day before yesterday, we're timesing by this minus 2. And so that's what this is doing down here. If you look, you'll see we have 3 here. We're minusing it by I. I is changing as we cycle through. So it's I is starting out as 0. And so that first loop is going to be 3 minus 0. It's going to give us 3. That's 3 times. And then get value. We're obtaining the close with an offset of 0. So this will start with the current day close, and then it'll go back to the left, back in time, whatever the value of I is. And so on that first loop, it's going to be 0, so that's telling us current day. And then the second loop is going to be 1, and so that's going to go back to the prior day close. And so when we do that, 3 minus 1, that's going to be 2, and then we're times, so the final product of this is the current day times 3, then it loops again, and now I is 2, or I'm sorry, 1. So prior day close times 2, loops again, I is now 2. The close day before yesterday times 1, and then we're done. So we'll go ahead and apply that. One thing I forgot to do here is after we finished with this calculation, what we need to do is we need to plot it. I'll say plot f equals numerator divided by denominator. All right, now that should plot. So we'll apply that. So we saw those lines are different. What did I do wrong here? I used 3 instead of 9, so we're going to do 9 here. Apply that. Beautiful, there we go. We got one line, and you can see they're both plotting behind this line, so they're both plotting the same numbers. Can't see the one behind it, but you can tell it's there from those numbers up there. So what's the point to all this? Well, if you just want to see these moving averages, there's no point. You can just use the built-in function here. But if you want to get in and dig into the actual formula that's used to calculate these moving averages, and you want to change some things and pull some levers, these codes will help you to do it. One small correction I want to make here: in order to get those lines consistent on an intraday chart, down here on this close, we would want to add period equals AGG to make sure those lines are the same.